Episode 3, Supercharged APM. Folks, welcome to the third episode of the AWS Cloud Operations Show, where problems meet solutions. My name is Kumar Jagannathan. I lead a team of worldwide specialist solution architects that focus on cloud operations. I'm streaming live from Atlanta, Georgia today. Well, I'm really excited about today's show. It's all about APM. What exactly is APM? APM stands for Application Performance Monitoring. Well, there are a lot of questions that I have. What does it mean for our customers? How is it different from traditional monitoring? Do I have to start over with everything that I'm already doing today? And who is this for? Is it for developers, for operators, for infrastructure engineers? Who exactly is going to be mostly getting benefited out of this? And well, why is everyone talking about all of these things? Well, there's a lot of questions, right? And to answer all these questions, we have assembled a great panel today, right? And welcome to our guests. Dear guests, first of all, thank you for joining the show today. And I really appreciate you taking the time to meet our audience. We'll do a round of introductions. We'll start with Surbi.
Hi, everybody. My name is Surbi, and really excited to be on the show. I have been at AWS for about 7 years, and I'm based in the San Francisco Bay Area. I lead product management for the suite of capabilities that we call Application Performance Monitoring, or APM.
Awesome.
Over to you, Siva.
Thank you, Surbi. Hey, everybody. My name is Siva Guruvaridiyar. I'm a senior specialist architect focusing on observability. I am streaming from Austin, Texas. And here at AWS, I've been helping a lot of customers, building and breaking things, etc. And super excited to be in the show. Over to you, Alex.
Thanks, Siva. Hi, my name is Alex Nazarov, and I've been about 15 years total at Amazon, 14 of which on CloudWatch in AWS. I'm based in Seattle, and I'm currently a principal engineer in APM space, leading development of application signals. Thank you.
Fantastic. Thank you, Alex. Thank you, everyone. All right. Surbi, so what exactly is APM? Like, can you enlighten the audience and help us understand what it actually stands for?
Absolutely. So this is a commonly used term whenever you're talking about observability. What it really means is the suite of monitoring or observability that you do to monitor your end user experience and how your applications are performing. That includes application discovery, tracing, diagnostics, digital experience monitoring, and really just helps your operators understand how your end users are experiencing all the software that you're writing. I mean, today, application monitoring is quite complex. Applications have a very complex set of dependencies. Operational data is siloed. You want teams, your own internal teams, to be able to quickly go and troubleshoot things, detect things, resolve them. And every issue in production is expensive to the business. So in a nutshell, are you measuring your real sort of end user experiences on your mobile apps and websites? That's a question to ask yourself. Which of your browsers are having degraded performance, or whether your app is delivering consistent response times across all your users? Are you able to pinpoint that third-party API or dependency that you're dependent on, and whether they're meeting your SLAs? These are all the questions that you would typically ask when you're measuring your end user experience via APM tools.
Right, that's great. So everything that you said, typically when it comes to monitoring and observability, people kind of think of collecting logs, talking about CPU utilization, memory utilization. It's more of from resource-centric point of view. Is there how is my resource CPU utilization in my EC2 instance, or how is my pod using too much memory? But what you're explaining to me is more of looking at the resources and putting them together in the form of an application point of view. And essentially, because nobody really wants to know, is my EC2 instance down? People are looking at, people want to know, is my ordering system up and running? Is my enrollment application delivering the performance that I want, right? So that's what they're looking for. And APM essentially serves what exactly customers kind of view their infrastructure as, which is in the form of applications. Perfect. Thank you for that. Alex, this question is to you. CloudWatch has been a great platform for customers to collect all those things that I mentioned earlier, like about collecting logs, metrics, and creating dashboards, alerts, and looking at it from a resource point of view. But could you give some background on the evolution of that and how that transforms into APM, or application-centric view?
Yes, you're absolutely right, Imai. So CloudWatch started as a collection of monitoring primitives. You have metrics, dashboards, alarms, logs, then we had a tracing. But application signals kind of brings it all together. You want to start your investigation or any operational activity with an overall picture of what services, resources I have in the application that I'm operating on. And is there any breach in operational goal that is shown in metrics? And how do I start troubleshooting, looking at the spike in latency, for example? And then I can get and look at the traces and maybe find the root cause. But even better, today we have an AI ops tool assistant that you can start your investigation while you're looking at some other things. The AI will try to troubleshoot and find the root cause and provide the hypothesis for the potential issue in your current application.
Right. So in the first ever episode, in fact, we talked about Q developer operational investigations, right, which is what you're alluding to. And I don't know if the audience remembers, but that particular feature also can make use of application signals data along with other information to kind of give to essentially investigate an issue or a problem that it's troubleshooting, right? So it gets in the data from different perspective, from resources, infrastructure perspective, and also from application perspective, which is great. This all great. Like, I think the audience really like to see demos, things in action, right? Siva, I hear that you may have a demo or two to show. Are you ready for that?
Yeah, sure, Emil.
All right, let's go with it.
Yeah, thank you, Imea and team, for the wonderful introductions. I'm going to show you guys a couple of demo, but I don't want to show you maybe a dry demo, like click here, click that, and all. For this, let's make it as interactive as possible, right? For this, we wanted to see the life of a service operator. So in our story, the hero is called Bob. Bob is our service operator and service owner who is responsible for this wonderful spring pet clinic that you are seeing here. So it's a typical pet clinic that you can see in your city. It's a top-notch technically. As a pet owner, you can take your pets to resolve their medical issues. So as a pet owner, you can register your pet, and then you can add insurance details, go ahead and then view your billing information, etc. Right? So in this case, this is the business we have been running, and Bob, as the service operator and service owner, is responsible to make sure everything's running smoothly. So in any issues, any time of the day, Bob is a person to go, and we are going to be seeing, in a day in the life of Bob, the different issues that he's seeing, and how, with the help of application signals, he's able to resolve those, right? So without that further ado, let's get started, right? So Bob is coming into the office, and once he comes into his chair, he's getting a call in his mobile, and then he's taking and then looking at his mobile. The call is from the CEO. The CEO calls and then says, "Hey Bob, my friend just now informed me that he's not able to book any appointments for our pet clinic. Can you take a look into it?" The request is coming from none other than the CEO. How come Bob can say no? Bob is going to say like, yes, let me go ahead and then see that, like, what's going on here, right? So Bob opens his particular, AWS console. So this is how, like, it's going to be looking like. He already enabled application signals. In this case, like, he's using a lot of microservices, as you could see here. Many of them are running in multiple languages like Java, Python, .NET, Node.js, etc. And he just wanted to see, like, the appointment service, right? So Bob, as a service operator, has created any SLOs or service level objectives. And service level objectives are basically your business metrics. You can tie that with your technical metrics. That is the metrics coming out of your services, right? So as you can see here, there is an appointment service. For availability purposes, Bob has already created an SLO with a goal of 95%. It should be available in a one-day rolling window. But currently, it is running unhealthy, and Bob wants to see what's going on. So for that, like, Bob clicks on this operation, and it is taking him to this particular tab called appointment service. Under that, like, there is a service operations. So from the charts, he's able to see, like, there is a request and availability. As you could see here, there are requests coming in, and then the availability is 100%. So no issues with that. And latency, occasionally we are seeing some spikes, but that is maximum is 600 milliseconds. We are fine with that. But what about faults and errors? We are seeing a lot of anomalies. And also, in the service operations, in the bottom section, under fault rate, we are seeing a 7% fault. Something going on here, right? So there is a 7% fault. And Bob wants to understand what's going on here. So it goes to the third chart called faults and errors. And then as we see, like, there are some peaks and valleys. Bob clicks on one of the peaks. And then this is going to be opening a drawer in the right-hand side. And here he's able to see all the transactions. As you could see here, there are a lot of 500 errors is happening, which is not good.
So these, sorry to interrupt you there. These are the transactions that happened at that moment in time when you clicked that chart, correct?
Exactly, ma'am. So at that particular point in time, these are all the transactions that came into the system. So with that one, like, Bob wants to take a step back and then understand on a high level what's going on here, right? So he clicks on this contributor insights. So this top contributors, it says there is only one alias called prod alias, and then there are some 5 faults in this particular time. So he clicks on versions, that is top versions by faults, and then here you are seeing, like, some interesting scenario, right? So there was a version called 5, which is having 100% available, and then all the requests have no faults at all, 0 faults. But looks like somebody has deployed a newer version, the version number 6, and looks like, more than 50% of them are failing. There are 9 requests coming in, but 5 of them are failing. So what's going on here, right? So let's go and see. So Bob wants to go back, click on one of the transaction, the trace IDs, and this is going to be opening up your trace details page. So from here, you're not only going to see your lineage. For example, in this case, the customer is coming through an API gateway and then directly coming through a Lambda here. But also you will be able to see the span timelines, each and every hop, how much time it is taking, all the information, and also the logs. So with this one, like, you don't have to open multiple tabs to go and figure out, like, what's going on in your application, right?
So in this case, it looks like the appointment service is the one that had issues and that returned a 500, which eventually got back to the user, right?
Exactly. So in this case, like, as you could see, there is a red icon here. So that means something is problematic. So just click on that red icon, and then there is an automatic dryer is going to be coming up. Click on that exceptions tab, and that's it. It says there is an null pointer exception, and exactly the line number is lambda function.py line number 27. As you could see here, Bob didn't even open the IDE. He didn't go through the code, or he didn't even open the logs. He was able to pinpoint at exact line number why this is failing and where this is failing. Now he can call the DevOps team and then ask them to roll back the version so that people are not going to be like affected. And also, like, he will be calling the development team, ask them to fix it. He will tell them like, hey, go and take a look into this particular line number 27 and then fix this null pointer exception, right? So with this one, like, Bob can easily pinpoint what is going on, like, under the hoods. He doesn't need to like, open the ID or something, but exact line number, exact problem, he should be able to see that. So this is how like Bob is able to do it, and then he can call back to the CEO and then says, "Boss, the problem is solved." Right?
Right. Yeah. So, well, great demo. I know you have more to show, but first of all, I don't want the CEO to call me and tell me that there's an issue in my application that I am supposed to own, right? How am I supposed to know that this issue already happened? Like, is there a way for me to know already without even before my CEO tells me through another friend who was using the application?
Exactly, Mia. So, like I mentioned, like this is where the SLOs come in, right? So here we have this SLIs are going unhealthy. So what you could do is when you're creating an SLOs, for example, let me show this quickly, right?
So just to explain what an SLO and SLI, all these terminologies are. SLOs are service level objectives, which is essentially a goal that is set for an application or an API for any parameter. Maybe it could be latency or the number of errors, or it could be anything. And you set a goal so you can measure against that goal. And SLI is the indicator that you use to measure where you are in that goal. At what are you like achieving the goal, or have you burned through the everything, the whatever wiggle room you had, and all of that, right? That's essentially what is in layman terms, correct?
Exactly, Mia. So in this case, like we have for your question of how they can be notified, you can even create some notification link here. For example, like if you want to be notified, you can create some alarms here so that it can be tied to your maybe pager duty or like Slack workflows and etc. So that you are going to be proactively alarmed. So in this case, like you don't have to wait for that to happen. So we have a warning threshold. In this case, like I can set it as 30%. So when that SLO is getting reached, even at 30% mark, you will be alarmed. Like in this case, maybe you will be getting a Slack message saying that, hey, something is not going right, go ahead and then take a look into it, right? So this way, like you should be proactively monitoring your system instead of like in this case the CEO has to call you and then say something is failing.
Got it. Yeah, that sounds good. So this SLOs are set, and then you set alarms based on where you are with the SLOs, and you get notified. Also, that could also be a traditional CloudWatch alarm as well, right? It could be just based on some metric also. Essentially, you get notified, and then you are able to simply go to your application and see what it's doing.
The beauty of SLOs is it really helps you prioritize amongst what's most important for you to address first. Like you may have a bunch of places where there are issues, but really what is the one that is most important to your end customer and to your business where you're exhausting the error budget. And then there are two types of SLOs you want to consider. For example, if you have like a service that has high traffic fluctuations, where a short period of poor performance can significantly impact that overall end user experience. So things like auto subscription renewal services, right? Payments, these can actually be these can be request based SLOs. And then if you have, let's say, like a search service or things with more stable traffic patterns where you want your performance over a longer period of time, you could look at a period-based SLO. So they're really meant to help you understand like how to set the right thresholds for your business, and meant for you to understand what to address first in that entire long table of SLOs that you just saw Shiva project.
Got it. Great insights there. All right, Siva, you have you're going to continue the demo, or there's more use cases? Okay.
Yes, we do have it, Timea. So let's move on to the next scenario, right? Like boss is happy, Bob is happy. So Bob is working, continuing with his work. And then again, he's getting a text message. So this time, like, he's getting a text message from his chief operating officer. So he says, like, he's as a customer of Spring PetClinic, he says like, whenever he's trying to get a recommendation from the service, like, he needs to wait a pretty long time. Also, whatever the recommendations provided by the system, it doesn't make sense for him. So he's asking him like, maybe can you take a look into it, right? So Bob wants to solve this problem, right? So he goes to service map. So service map is basically like, it's a dynamic way of creating your infrastructure, like, your applications. And then as and when your signals are coming in, we are creating this dynamic map so that you can be able to see like, how different applications and services are talking to each other at any point in time, right? So as you could see here, like, this is a complex map. He doesn't want to like, break his head and then see like what's going on here. Since the COO mentioned that the recommendations, so as a service owner, Bob knows this is something to do with AI, right? So today we are using Bedrock for that purpose. So Bedrock is AWS generative AI, or like, AI framework that you can use it. And even in Spring PetClinic, we are using Bedrock models to provide the recommendations for our customers. So in this case, so if you can see that, we are using like, two different models. One is a Titan Express model from Amazon. So as you could see here in this one, and then the next one is a Claude model.
It's a little too small. If you could, if you don't mind zooming in a little bit.
Sure.
Yes, that helps. Thank you.
Yeah, so we are using two different models. And as you could see in the right drawer, this is being used in a microservice called customer service. And this is taking like, the latency is more than 11 seconds for Claude model. And then for the Titan Express model, it's almost like 10 seconds, which is not good, right? So let's go and see like, what's going on here. So just click on that customer service, and application signals knows this, like, you wanted to go and see the dependencies. So it is directly taking you to the third tab here called dependencies tab. And then from here, it shows you are using Bedrock runtime. And then from here, like, it's showing you are using Titan Express model. And then the P99 latency is even worse. It takes like, 40 seconds at the Titan Express model. And then for Claude, it's taking around 20 seconds. So this is aligning with what our COO was telling. It's taking more time. Why it is taking more time, right? So let's go and identify. So in our latency chart, we are seeing like, it's going all the way from 20 seconds to 40 seconds. And we want to understand what's going on here, right? So let's click on one of the peak here. And again, as usual, your right-hand side, the drawer is going to open. So here, this is the transaction that we are talking about. Let's click on this one. So here, let me zoom out a little bit so that you will be able to see that. Okay. So in this case, the user is coming in to the PetClinic front end, and then they are going to the customer service, and then they are calling the Bedrock runtime. And this is how the flow is going. And now we wanted to see like, how this particular prompt, what is the prompt we are asking for the model, and then what is the response we are getting. As you could see here, like, we are seeing so many log entries. To effectively see what's going on, click on this particular link called View in CloudWatch Log Insights. So this will open up your Log Insights tab, and you don't have to worry about like, populating all the fields. By default, the log group name will be populated for you, which is a demo application. And also the query also will be populated for you. And all you need to do is just run query. That's it. And here you will be able to see all the 23 or so entries from this particular logs, right? So we wanted to know like what is the prompt we have been using. So let's filter that out, right? Say filter message like, then prompt. And again, run the query. So you're filtering it out. And then we wanted to see only the prompt that we have been using, right? So let's take a look into it. So here we are able to see like, there are 3 different log entries. For example, so this is what like, we are invoking the Titan model from Amazon. And the token count is 9, but the generated token count is almost 1,000, more than 800 tokens. So this is the prompt we have been asking. What is the common diseases for a cat? Which is pretty generic statement, which I don't think it is going to be beneficial for the customer, right? So as you could see here, we are providing a long information, it could be like feline asthma, or it could be common diseases. Cats should be parasites, etc., right? So this is what we are asking to the Titan Express model. What about the Claude model, right? So let's go and look into a Claude model. So in this case, so this is the one we are calling the Claude model. So here we have been asking the question about the same thing. What are the best preventive measures for common cat diseases? Even the model itself says, I cannot provide a veterinary advice or diagnosis cat diseases, and it is giving a general tips. So now we know the problem, right? So we have been asking a very generic question, and model itself is saying it's very general, so that you guys need to give me a focused effort on all those, right? So now what Bob can do, so he can go back, and then as you could remember, we are calling our customer service directly the Bedrock runtime. Now he can call up his GenAI team and then ask them to take the pet information from this particular database and then tweak this prompt so that it's going to be what are the diseases for my cat with XYZ medical conditions, right? So that it is going to be going to give me a crisp response from the model. So it's going to be helping reduce the latency, and also it is going to be helpful when it is reaching the customer instead of giving a generic advice. So with this one, he will be able to see, or he will be able to identify this Bedrock issues, and then he should be able to sort it out.
Right. Well, essentially, just to be clear, so this is an issue in the service, not necessarily in Bedrock, but the service wasn't asking a more narrowed down question. It was being too generic, and because of which the model that is being used in Bedrock is giving a generic response, which happens to take a longer time, not being too useful, which results in this whole episode of my COO texting me. And by the way, this company is amazing. CEO and COO, they are all super friendly. They just text people when things go down. Fantastic. I love that company. Is there a name for that company? PetClinic company? That's what it is?
It's just
whatever.
A clinic, right?
Okay. All right. Okay, that's great. So this is all cool stuff. And I'm a little bit kind of lost on how you got here, right? I think this is amazing. Everything you showed, lots of data, a lot of useful information. Mainly what is super impressive is with how it automatically identified dependencies of these different services, and all of that was shown there. And first of all, two questions here. One, where is this application hosted? On what infrastructure? We'll start from there, and I'll come to the next question afterwards. And how did you set it all up?
Yeah, so here, we have been using two major compute platforms, even though Application Signals works on all major compute platforms. So here you are using EKS cluster. For example, let me show you this real quick. So in EKS, we have a demo cluster wherein we are running this multiple applications, the services running in multiple languages. As I mentioned, the services are running in different languages like Java, Python, .NET, Node.js, etc. And to enable this application signals, it's pretty straightforward, right? All you need to do is go to your EKS cluster, go to your add-on, and then there is something called Amazon CloudWatch Observability. Enable this add-on, and that's it. You don't have to do anything else. So behind the scenes, it is using OpenTelemetry standards. So it will automatically ingest your metrics and traces, and then it will send to CloudWatch. So that's
that's where I'm going to go to Alex. Alex, give us some insights into how this thing works. I know Siva talked about adding this add-on, which is essentially a Kubernetes add-on, right? And it's called Amazon CloudWatch Observability. And then what happens once I do that?
So we streamline all this telemetry data in what is collected by application, and we streamline it as a log stream. And then from this log stream, we derived metrics, and we also use spans available in the logs for searches as well. And one more question I want to address is when you asked about dependencies, how we determine dependencies. Just overall, we in Application Signals wanted to channel this mantra we have within AWS when we operate our own services. So for us, taking a dependency means we have to pretty much own it in a way, like totally understand how it works, what its latencies are, and even have it on our dashboard the same way we would monitor our own application. So we try to channel exactly this mindset when we build application signals. So all dependencies, they up front and center and available to troubleshoot. They have all the golden signal metrics, graphs, and you can navigate to traces from there as well. Does this answer your question?
Yeah, it does. So I think basically the CloudWatch observability add-on is doing all the magic that is needed, and that is collecting the signals that are required. That includes spans and metrics are calculated. Is that, did I understand correctly?
Correct. The metrics are calculated from spans. We have several modes of operations when metrics actually collected from the application and sent as statistical sets. So in that way, we ensure that we represent the entire data set that application operated with, while spans could be sampled.
Got it. Okay. So that essentially gives us this visibility. You mentioned this term called golden signals. What exactly are they, and why are they important?
Yes. So it's an industry term. They call the RED metrics, RED, request, errors, duration. So we in Amazon have a little bit extended set of golden signal metrics. So we do differentiate between different kinds of errors. So specifically, we say there could be server fault or user error. And so for us, those four metrics are golden signals. And this is what we capture in application signals. And we do this not only for operations processed by the hosted application, but also for every dependency, including additional details. So for example, we not just will tell you, oh, your microservice invokes S3. We will tell you which particular API, let's say it's get object in S3, and which particular resource, so specifically which bucket in S3. And then we can actually have a view that you may have different experience calling different APIs or different resources.
Got it. Sounds good. Yeah, thank you. So if I understand correctly, once again, just to kind of recap, I have an EKS cluster. Let's say I have a .NET application or Java application, and I install Amazon CloudWatch Observability add-on. And as a developer, is there anything specific that I have to do for this magic to happen?
Sorry, could you please rephrase the question?
Well, so what I'm asking is, if I have an application that is running on an EKS cluster, right, and I enable Amazon CloudWatch Observability add-on, and as a developer, is there any specific action that I have to take before or after enabling this add-on?
So there is one more step today in application signals. You have to essentially enable or start discovering all, as this telemetry comes into CloudWatch, it is being stored as logs, but then enabling discovery allows application signals to detect this application structure and metadata from those logs.
Right. So it's still important to like kind of name the service and group the applications together, so it's a little bit easier to put them together. I guess
So one
that's
thing is we actually do best effort of choosing the most appropriate defaults for service name, for environments. So for EKS, for example, we're using workload names. So customer, like our users or developers, operators, they already thought about what would be a good name for the service, so they put it as workload name in YAML file. And we would actually capture that and use that, present it as a service name. So we try to speak our users' language as much as we can, but they can always override to reorganize the structure the way they like.
understood. And instrumentation wise, as a and this uses open telemetry and there is auto instrumentation involved.
Yes, we are we based our auto instrumentation on hotel libraries, and it is a drop-in enablement. Essentially, you do not need to change anything in your code. You just need to include additional library with it.
Got it. Yeah, that's exactly what I think I was trying to drive. So if you, as a developer, the effort for you to get to this thing happen, this thing application signals happen, is not very much. You don't have to like rewrite the entire application and do all too much heavy lift, right? Is there anything you want to add, Surbi, to that?
Yeah, I think it's great to see that developer perspective on how easy it is to get started. We make it extremely easy on the operator side, where you are, let's say, operating a set of services, to now see applications running on EKS, your serverless applications, applications hosted on EC2 or even on-prem, Kubernetes, all of them in a unified sort of view. And so that really is, and now you can say all your SLOs are overlaid on all of these. You can prioritize what's really sort of the issue that you want to troubleshoot first, running out of an error budget. And then from there, go directly into the APIs and dependencies, and then to that individual transaction, and then the line of code. So that's really the beauty. The application signals experience is built keeping two things in mind. One is standardizing these experiences so that when you're, let's say, monitoring an EKS application versus serverless application, you're not radically looking at different things. You have a standard set of golden metrics that are meaningful. And then the other is, as you can see, I mean, somebody like Bob would maybe take like maybe hours putting together all of these correlations, which, I mean, she was able to do in about 3 to 4 clicks. So the idea is really how to bring the right nuggets of information so that you can troubleshoot faster, but in a logical and meaningful flow.
Sounds good. Thank you. Siva, you want to continue the demo? Sorry, I interrupted you and made you go through the infrastructure part.
No, I think it's a very interesting conversations. Yeah, let's go back to Bob here, right? So Bob is continuing with his work, and this time, like, he's pulled into a support call. So support engineer calls Bob, and then he says, like, there is an angry customer on the line, and then she says her order is not going through. So as a customer, she's trying to put a nutrition order for her pet, but it is not going through. She tried a couple of times, it's not working, and she's a premium customer. So support is very much afraid that this particular issue has to be resolved. So that's why they are pulling Bob to the conference call. So at this point in time, what Bob knows about is only this particular pet owner called Shirley, her ID, maybe that is number 6, and then what are the order ID. This is like more like finding a needle in a haystack, right? But we have an angry customer on the line, so we need to give some response to the customer so that, like, what Bob is going to do it. So this time,
right, but also, I mean, just to add context there, which is very much in line in a real world scenario, which is what happens, and no one, like tells you that, hey, what happened to that particular server that's just being slow. People say that, hey, this customer who's using this application is having an issue, and go fix it, which is the information that Bob got right now.
Exactly. So this time, he goes to the transaction search. As you could see here, it's a newer feature which we launched during this reinvent just 2 months back. So you can go and Bob is going and then giving the order ID, right? So that's the information. That's the only information he knows about. So he just put this order ID, which is we got from the support 841788, and then he just goes and then maybe in the last 3 hours run the query, right? So this one is going to be wherever this order ID is being used, it's going to pull that information.
And
So,
this order ID is a custom attribute that was captured from the application, right? That belongs to the application. And because you know that it exists, you're able to go simply filter on that.
yes. So this particular custom attribute, like you mentioned, Umia, so this is what being used in two different spaces. One is a payment service, then there is an audit service. But Bob is seeing there is a 400 error in payment service, and there is a trace ID here. So he clicks on this particular trace ID, which is going to be taking him to the trace details page. And this is how the flow looks like. Looks like Shirley came into the system through the front end, and then she is doing a payment for this nutrition information. So as in typical microservice fashion, payment service is calling multiple other services, for example, customer service, and customer service is calling insurance service to get the insurance information. Then it is trying to place an order through nutrition service. So it is failing at the customer service. So there is a red icon here. So just click on it, and as usual, go to the exceptions tab, and that's it. So it looks like there is a 404 error, which says the nutrition information that Shirley is looking for their pet is not there. So now Bob can unmute himself in the call and then tell Shirley that, hey, Shirley, we are very much sorry for the inconvenience caused, but the nutrition information, the product that you're looking for is currently unavailable, but we will make sure to give you a replacement so that your pet is going to be taken care. And also for your inconvenience, we will be giving you some credits so that you can use that in future. And thank you for your support, right? So this way, Bob is able to pinpoint, finding a needle in a haystack kind of a problem in just a couple of clicks. He just goes and then put the order ID, and with a couple of clicks, he was able to see, exactly why this is failing, right? So with this, you should be able to do that easily.
Right. So the way it worked is this service called Payment Service, which is a .NET service, which made a HTTP call to a Java service called Customer Service, and the response had an exception returned from the Java service because Java service is the one that failed. So the exception was caught. The entire stack trace was caught in the response and sent back to CloudWatch through the mechanism that the plumbing mechanism that exists with the Amazon CloudWatch add-on on EKS, correct? And it was able to stitch together the whole thing because there was a correlation ID, or in some ways a trace ID that was assigned throughout the entire request. And but you got in there knowing that there was an order ID, because order ID is a custom business related data that you were able to inject into that trace data. So it's not only the underlying the trace related IDs that are getting captured, but also the custom business related things can be captured, and not only captured, but also can be used to troubleshoot, which is basically what you just demonstrated.
Exactly.
Got it. So I have a question. So yes, this is EKS, that's great. There are many customers that also have, they're migrating to AWS and they have some on-prem resources, right? What happens? Are customers able to use the similar mechanism? Maybe Alex, you can provide some insights on that.
Yes, so we do provide our instrumentation in self-serve fashion. So customers could download our instrumentation packages, a CloudWatch agent, and run it on premise. And that way we could receive the same type of telemetry, stitch things together, and present how their internal application works. And even better, we will show when those self-hosted services when they call AWS resources. We treat that type of dependency as a first-class citizens in application signals. We'll have all the details about API calls made to AWS services and resources.
Got it. Awesome. So that is great to know, because that is kind of a typical situation where, of course, there are cloud native applications that customers are building, but more often than not, there are customers who are slowly migrating a workload, and there is a portion of it that has to be on-prem because of a variety of reasons. So CloudWatch not only can watch cloud, but also not cloud environment. That's kind of a joke. All right. So Siva, yeah, let's continue. There's more use cases you want to demonstrate.
Yeah, so let's go to the last use case, right? So Bob is doing all the job, but he just wanted to go for lunch. It's lunchtime almost. So he wanted to go for lunch, but he's been approached by Alex, who is just a new joinee to his team. And then he looks terrified. So Alex says, there are some things which is failing. And then he's seeing some errors from the SLOs, unhealthy SLOs and all those things. And he wants Bob's help. So Bob being Bob, he's so nice. So he just wanted to help Alex, right? So he goes in and then look into Alex's screen here. So this is what Alex is showing. So the same thing, PetClinic application. So we have this architecture is we are getting the feedback from the customers. So basically, using an API gateway, it is being received by a Lambda called feedback receiver. And we are taking that feedback and then feeding into a Bedrock runtime engine to categorize that as positive or negative feedback. So if it is a positive feedback, everybody's happy. We don't have to do anything. But if it is negative feedback, as a customer of such company, we wanted to reach out to the customer so that the feedback receiver for the negative feedback, it will call another feedback called ticketing system Lambda to create a ticket so that we can have a follow-up, right? So what Alex is mentioning is he's going to the SLOs and then he's seeing for the first time there is an unhealthy. So we have created an SLO for this feedback service and it should be available 99% of the time, but currently is unhealthy, and then he's kind of terrified. So he doesn't know what to do. So Bob, instead of giving a fish, he wants to give a fish to Alex, teach Alex how to do that one, right? So in this case, he goes in and then says go to this particular feedback receiver Lambda, and then he clicks on this unhealthy thing, click on this investigate. So this is going to be opening up Amazon Q developer operation investigations, which we saw in the first episode of this particular show. So what it's going to do is, instead of me as a human doing the job of correlating this metrics, logs, and traces and coming up with a conclusion, he's going to be coming and then it's going to be doing that job by this particular automated robot, right? In this case, the Q developer operation investigator is going to be doing that. So here you can click, you can start a new investigation, or if it is an ongoing investigation, you can add it to an existing investigation also. So in this case, you just give a name, for example, test, and then that's it. You just say start investigation. So it's going to take maybe a couple of seconds or a minute or so. But since we don't have a lot of time, let me go and show you how it is going to be opening up, right? So under AI operations, you go to investigations, and then I ran this exercise already for this demo. So if you can go there, so this is all the hypothesis that Amazon Q developer is coming back. So it basically says that feedback receiver function, it's experiencing a timeout error when calling the ticketing system Lambda. So it looks like what happened is there was a negative feedback. So feedback receiver Lambda wanted to create a ticket. So it is calling a ticketing system Lambda and it is timing out. So here is where it is mentioning about a cold start of ticketing system function, because it is taking around 3 seconds for initialization, right? So now it is so easy for the junior developer to make sure how to approach this problem. So not only it is saying what exactly the problem is, and also it's saying what are the possible next steps are. For example, it says you can have provision concurrency for the ticketing system Lambda, so that multiple instances of ticketing system Lambda can be running. And also the current timeout settings, of the source lambda, you can increase it so that it is not going to be timing out, etc. So now things are good, but we have two different questions, right? Number one is, as a junior developer, what exactly you mean by this cold start of this ticketing system function? And the second one is how it is doing it. It works like magic, right? How Q developer is able to figure out this is exactly the root cause. So for that, the second question, just click on the show reasoning, go to this particular trace based on which it came to this conclusion. So from here, it's going to be showing you like, it's coming through an API gateway. The feedback receiver is calling the ticketing system lambda, and then it's failing here, right? So if we go a little down, it says the ticketing system lambda, if you could see here, the init function is taking 3 seconds here. So it is basically seeing the data. With the data, we were able to see, like, this is what the root cause is. And like it is mentioning, we can give back, like, you can either increase the provision concurrency or increase the timeout value, etc. So that way you can do it. And just for the last one, for the cold start issue, even the junior developer, like, you can go and ask the Amazon queue, what is cold start? And then it will be going and then teaching him what is a cold start problem and then how he can go ahead and then look into the things, right? So this way, like, it's easy for even a junior developer to come and look into the system with all these things, like, with Amazon Q developer operation investigations, able to guide you on a step-by-step basis, like, this is the root cause and these are all the possible next steps that you can take it. So that's about, like, the demo part. And again, like, if you want to be a Bob in your organizations, go ahead and then explore application signals.
Well, I can be Bob if the CEOs can text me when things go down. All right, that was really cool. And we touched upon Lambda, but I'm curious, like, how do you enable these things in Lambda? Can you show that?
Yeah, sure. In Lambda, it's pretty simple. You can go to your Lambda console, and then in this case, for example, this ticketing system Lambda, you can just go to your monitoring tab, close all this, and then you just say, like, enable application signals. So once you enable, so that will be an application signals, enable application signals will be there. Once you
I think
enable,
that's in the configuration tab, isn't it? Like where you have all the monitoring
exactly.
and operation tools. Yeah.
Exactly. Yes, you're right. I was confused. So here, like, you will be having, like, the CloudWatch application signals. Currently, it is enabled. So you can just go ahead and then enable it.
What happens when I enable? Alex, like, how does that magic happen?
So we have designated channel of that telemetry that Lambda sends to CloudWatch logs and traces. And that's why another reason why enabled with application signals, Lambda does not take itself cold start, does not suffer much from this cold start because the piping is extremely lightweight. And that's how we, and from after that, it's all standard. All the spans and other telemetry is actually searchable in OTel format in CloudWatch logs.
Got it. So can you click on the edit button? I'm just curious to see. Okay, so all you have to do is simply click on that enable checkbox, and we have support for Node.js, multiple versions of Node.js, Python, again multiple versions, Java, .NET. Okay, which is quite exhaustive. And as a developer, again, a developer, I'm just writing a simple Lambda function to do a certain thing. I don't have to do anything extra, right? Like the layer that is getting automatically injected into my Lambda is going to take care of that. That actually contains the auto instrumentation kind of piece, the binary.
Yes, and it's a small pinch on maybe additional size that Lambda will need to utilize in memory, but it's not very significant, and most of the time you already have enough headroom in your Lambda to accommodate for it.
Got it. Like what you're saying is this should not cause a significant kind of penalty, performance penalty.
Exactly. And memory usage penalty and performance penalty, both are minimized.
Understood. Got it. Okay. Sounds great. So yeah, sorry, Subi, you were going to say something.
Yeah, I wanted to add that, I mean, folks may be wondering like how this is all priced as well. And last reInvent, which is December 2024, we launched a simplified bundle for application signals and the transaction search that you saw Shiva present. And it's actually quite cost effective now. You are charged on ingestion, which is like how many the GB of application metrics and spans that are ingested in CloudWatch, and this is tiered for scaled usage. So as an engineer, you can do what you call elective instrumentation. Like you can have high volume transactions like search products be looked at more at an aggregate level, and versus like payment products and low volume transactions but important to the business. You can have full coverage. And the other dimension that we charge is on spans that are indexed as X-ray trace summaries, and 1% of those spans are indexed at no charge. So this has really been resonating well with customers, where they're able to now monitor like full set of transactions of their applications that are important to them.
Got it. No more sampling, right? Like that's basically, I mean, with sampling, there's always, okay, do I do head-based sampling? But a lot of people want to do tail-based sampling because they want to capture all errors, but mainly because of cost. The whys, if you ask the whys, it's all about costs and the eventual performance of the system itself. But what we're saying is that's not a concern anymore. Just capture.
You have the fine-grained control, but ideally you should be able to capture in a more cost-effective manner. That's right.
Right. Got it. Thank you. I think that was great. And is there any other points that we want to cover? We have the last couple of minutes.
Maybe some call to action. We do have there is a one observability workshop that you can go ahead and then use that. So we have this one observability workshop. Let's go and
I have that. Yeah, we have the workshop, and we also have everything that you shared. We do have an interactive demo, right? Like we have that. That customers can simply go and experience that as well, right? And let me add that to the stage, but it asks me to remove your screen. So let me just quickly, or maybe, show that. That's actually better. And the links to all of these things are in the show notes, in the description of the video. So just go to the video, and in the description you should see links to what you're seeing on screen. So everything that Siva showed, you can without even having to deploy anything, install anything, you can simply click on the link and actually kind of like touch and feel like how it looks like. And I know it's much easier for you to understand because you will be able to take it at your own pace. It's not video, it's interactive. All right. This has been very, very informative for me, and I learned a lot. And this is a lot of stuff, and I really appreciate how we are looking at solving these problems from customers' point of view, right? Like I think I'm repeating myself here, but we all want to know how my application is doing, and I really don't care what that pod did or that cluster did or whatever, but I want to know if my application is up and running. And that is the point of view that that customers are looking for, and we are solving for that, which is quite exciting. And Subi, I know you have the whole roadmap slide that you want to show. Just kidding. That's my standard joke that I make. But anyway, thank you so much for you all for joining the show. I think this was, like I said, this was quite an educational experience.
Thank you.
Thank you. Bye-bye.
All right. Thank you all. Audience, thank you all for joining. And We really appreciate your participation here. See you all in 2 weeks.